And now for a tiny exercise, okay? And we have the store, Nilla, and they want to see how advertising affects the sales of some canned goods. And they want to see how the number of pages in like an advertising circular affects the sales of these goods, which means that they have to vary. They have to have variation in the X variable, which is the advertising pages. And then they are calculating the sales on the back of this, okay? And now we have some questions, and that is, explain why these data do not satisfy the linear condition. Okay, we see right off the bat that the residuals for low values of x, which means, always think of it in logical terms, it means few advertising pages, results in, or is associated with low value of sales. Okay, and then you have for this section in the middle, you have these positive residuals. Okay, you have these positive residuals, positive and negative. Okay, and for large amounts of or a large number of advertising pages, you have these negative residuals again. Okay, so you see, you can find a pattern in the residuals. Okay, and whenever you can find a pattern in your residuals, then some warning signs have appeared, right? And there's something you have to change. And here we go from, I was supposed to say, from negative to positive to negative residuals again, which indicates that we are dealing with a non-linear pattern. Okay. And question B, which change in advertising pages appear to have a larger effect on sales, increasing from 1 to 2 pages or 4 to 5? Okay, and we're just getting rid of this. Okay, and well, actually we can get rid of everything. So going from 1 to 2 pages or 4 to 5 pages, okay, which has the larger effect? Okay, for 1 page of advertising, sales is in this region, right? And for 2 pages, sales would be in this region. So you would have like an upward sloping relationship, you might say. And from 4 to 5, you would actually be kind of a flat. You would have like a flat development in sales. So obviously, going from 1 to 2 pages of advertising has a greater effect on sales than going from 4 to 5 pages. Okay. So what transformation does Tukey's bulging rule suggest? Well, here we see that our pattern is upward sloping, but it's tapering off, so it's concave. And if we go back to Tukey's rule, we have just the same pattern here. So what we are looking for is to make a transform of the x variable, and which means that we are taking the logarithmic transform of the advertising pages. So this would be ln of x. Okay, so that was a tiny exercise, but now back to the cat food example. And what you can do is that after you have regressed the logarithmic transform of sales volume on the logarithmic transform of the average price, you can plot the scatter plot, okay, with the y hat, okay. So this is the what do you say, the expectation from the, oh my gosh, log regression. Okay, so and you see that the model follows the data quite well here. Okay, and if we just plot the residuals versus the x variable, and try to look for a pattern, we can't really find a pattern. Maybe the volatility of the residuals are higher for higher values of average price, but with this data we can't really say. What we're interested in is whether or not we have captured the non-linearity in the data, and it actually seems like we have. So now we can compare the linear, let's see, yeah, the linear and nonlinear equations, and you see that for the linear model we have a certain intercept and a certain slope, and we have an r squared of 0.92, which is quite high. And for the logarithmic transform, we have a vastly different intercept and a vastly different slope. Okay, like this. Okay, and since we have different y variables, okay, this is the y for the log model, and this is the y for the linear model, we can't really compare the r squared, even though the r squared is higher for the log model, and visually we could see that the log model fit the data quite snugly. We can't really compare the r squared because you really this logarithmic transform transforms the original variable to a logarithmic variable, and so it's a vastly different variable. So you're really making a model to explain something else, right? So that's why we can't really compare the r squared or the standard error. And to get through this, or to get by this, we can plot and just make like a visual comparison. And here you have the log transform, and this is like a prediction, and this green line is the linear prediction. Okay, so you see that the log prediction follows the data more accurately. Okay, so it's not biased, whereas the linear prediction, it's biased downwards for low average price, it's biased upwards for medium average price, and it's biased downwards for high average price again. And what can we do with this log regression? It's actually quite useful, because if you have a log regression, you get the slope, which is the elasticity. And from your microeconomics course, which you probably should repeat, it's always good to review stuff. You find the optimal price of a good is actually based on the cost. Okay, and here you see that, well, if cost is 0, then you get a 0 optimal price. So we say that cost is different from 0. Okay, or yeah, and the elasticity has to be an element of the range from negative infinity to -1, never including negative 1, because if you have an elasticity of -1, then the optimal price would explode into infinity. Okay, which is not really realistic. Okay, so now you can just think about, what is the elasticity? Well, elasticity is just like the percentage change in x. What kind of percentage change in y would you expect? Okay, and remember that this is negative, right? So you have a change in x along this axis, and then you have a change in y in percent downwards. Okay, so this elasticity is negative. Okay, so what we do is just to take a log regression and find the slope, log of y and log of x, and you find the slope. Okay, and in our example, we found that the slope was negative 2.41. So then we understand that if we increase the price by 1%, then we would expect the sales to decrease. So 1% up would decrease the sales by 2.41%. Okay, and if we just put in an make an example here, that we have like the store and it sells cat food, and the cost is 2.7, okay, and we have the elasticity. The elasticity is negative 2.41, and we can just plug in the numbers, and we get the optimal price of 4.61, which means that the store's profit is maximized when the price is 4.61. Okay. So to summarize, this lecture is that well, we have spoken about linear models and non-linear models, and to see if you need a linear model or a non-linear model, you should just plot your data, and scatter plot is a really good way to find that relationship, okay, visually. And you just check if there's curvature in the relationship between x and y, and if there is, then by Tukey's rule, you know what to do, okay? And most importantly, use your intuition and economic knowledge. Okay, this is vastly important, because then you really ask yourself if a change in units, oh, sorry, my writing is really off today, a change in units or change in percent. Okay. So should the x variable change in units or percent, and should that correspond to a change in units or percent of the y variable, okay? And we have seen that when we look at price and quantity, then we look at percent. Okay, that's it for today.